So our next speaker then I'll introduce is Vicent Briva-Iglesias, who is just starting as a PhD student at Dublin City University in the Digital Realities Research Centre. He's going to be looking at interactive machine translation. We've seen that come up already today as an interesting topic. But today he's going to talk about some of his previous research about a different ethical machine translation being possible. And he's focusing in on English, Catalan, free open source NMT. So I will hand over to you, Vicent, and I'll give you a little interruption after 15 minutes, okay?
Perfect. Can you hear me?
Yes, we can. Thank you. We can see
Okay,
the slides.
perfect. So first of all, thank you everyone for attending, and it's a pleasure to virtually meet you here. And as Sharon commented, I'm going to talk about a different ethical machine translation that is possible, and in this case, specifically on English, Catalan, free open source, and MT. Okay, first of all, I'm going to talk about the current context of machine translation for low resource languages, specifically for Catalan. And then I'm going to present some methodology I have previously worked on, as well as the results from that study. And then I will follow with the effects and use cases and the impact machine translation for low. Right now, I'm going to talk about the current problem or the situation, the context of machine translation. And first of all, we need to know the context of Catalan. For example, Catalan is not famous as much as Spanish language. Catalan is a co-official language in Spain, here in Spain, and it's spoken in the Valencian country and in Catalonia. What happens that it cohabits with Spanish, and Spanish is one of the most spoken languages in the world, and that has some effects and consequences. For example, in Valencia, we live in a diglossic situation where Spanish is the language A, while Catalan is language B. This means that language A, Spanish, is spoken in politics or even to talk to the administration, but not Catalan, that it's only spoken it's more in small and colloquial atmospheres. Nevertheless, in Catalonia, the situation is the opposite, because Catalan is the language A and then Spanish is language B. Yet, this situation is changing in Catalonia too, and it's going and following the path that Spanish is getting stronger and stronger, and Catalan is losing its strength. But then, after speaking a bit on introducing the context of Catalan, that can be the same with any other low resource languages, we have to talk also about neural machine translation requirements. Statistical machine translation or previous paradigms, for example, role-based machine translation or statistical machine translation, required computational power, but it was not huge. A normal translator, for example, me, that has been working as a translator for 4 years, could build it or my own. I could build my own machine translation system using different systems, such as, for example, M-Tradomatica. But what happens? Now, NMT requirements or neural machine translation require huge computational power, GPUs that are not available to normal translators or small groups of translators. In addition to that, we need to add the difficulty to find high resource or high quality corpora for low resource languages. As in the previous conversation or in the previous presentation, English, Spanish corpora are available on the internet because we have European Union Parliament proceedings, then we have also legislation, but we can find that high quality corpora for low resource languages such as Catalan, because there are some places where it's even difficult to find it spoken. So imagine finding high quality corpora. And then just in the situation we have all these or meet all these neural machine translation requirements, we have the GPUs or we have the huge computational power needed, and then we find the corpora. What happens now? Okay, then you need to know how to build a machine translation engine and computer literacy. That's also a really big problem currently, because it increases difficulty to train and to create a machine translation engine that not everyone can do right now. And then the fourth problem is probably data privacy. With commercial platforms, empty platforms like Google Translate or DeepL, for example, confidential information of ours, of our clients, or even from our own information may be at stake. So what happens now? What is the impact of open source MT for low resource languages? The research questions I wanted to present were which MT engine evaluated, that I will present them later, offers a higher translation quality, then which MT engine evaluated offers a bigger productivity increase when introducing it into a translation workflow, and finally, can a free open source MT engine for a low resource language beat the flagship MT engine for the English-Catalan language combination? In order to do this, I have evaluated 3 MT engines. On the first hand, it's Apertium, that is a free open source rule-based machine translation engine, and it was originally developed for closed languages, for example, Spanish and Catalan, but later some other languages, like for example English, has been added. Then we are also evaluating Softcatalà Translator, that it's a free open source English-Catalan neural machine translation engine built with OpenNMT. It is fairly new from the beginning of this year, and it has been trained with TMs from the Softcatalà project. Softcatalà is an organization, non-profit organization, that works in order to defend and to increase the presence of Catalan on the internet. So they normally work with localization, software localization projects, such as, for example, for Mozilla and BLC media player and all that stuff. And it's kind of an in-domain MT engine of software localization. And then the third MT engine evaluated, it's Google Translate, that everyone here knows it. It's a flagship of commercial MT. It uses neural machine translation from the beginning of 2020, and it includes thousands of language combinations, including English, Catalan. Then, when we have the engines, we need a text in order to evaluate these engines. So I used Home Assistant.io, that it's an open source smart. Why is this important? Because I could download all the strings from GitHub, then prepare the text with a copy framework, and finally choose the segments randomly in order to create the text to be evaluated. Once we have the text, the most important thing is to set up the experiment. Then automatic evaluation. We know automatic evaluation is really important and really cheap, but it's only useful for developers to know if all the amendments introduced in the systems are going or are following through the right path. Unfortunately, or not unfortunately, human evaluation still is the golden standard, and thus I did 3 different human evaluations using DQF tools by TAUS. First of all, we did a relative ranking evaluation with 11 professional evaluators of 200 segments. Here you can see the interface. There's a source segment and then 3 target segments with different raw output proposals from the 3 different engines. The evaluators had to put number 1 to the best translation or raw output proposal, and number 2 to the second best, and a 3 to the worst one. There was also a possibility to put a number 1 to the best output proposal and then to put a number 3 to the other 2. After this first human evaluation on relative ranking, we did an adequacy and fluency human evaluation. Same 11 professional evaluators evaluated 100 segments. This is also the interface, the user interface of DQF tools. In the source segment, we can see it there, and then we can also see the target segment. It's highlighted. And then at the end of the screen, we can see how we can evaluate fluency and adequacy. First of all, we could put incomprehensible fluency, disfluent, good or flawless fluency. And regarding adequacy, we could evaluate them as of the meaning is preserved, little of the meaning is preserved, most of the meaning is preserved, and everything was preserved in the raw output translation. After doing these two human evaluations, we obtained user perception and a human quality evaluation of our evaluated MT engines. After this, in order to do a more thoroughly evaluation, we undertook a third human evaluation that was a post-editing evaluation. In this case, we reduced from the number of evaluators from 11 to 6 in order to get data that was more easily, that we could analyze more easily. And then we divided two groups of study. One first group of study that were 3 professional translators evaluated Softcatalà translator, neural machine translation, and then Google Translate. And then the second group of study was 3 volunteer evaluators that evaluated Softcatalà translator with Apertium, both open source and machine translation engines. And then we evaluated 2 texts of 100 segments. I will explain why there are 2 texts later. Here we can also see the interface from the QF tools. There's a source segment highlighted, and then there's also a target segment where evaluators could post-edit and amend all the necessary things from the raw output in order to get a human quality or human-like translation. They had to do a full post-editing evaluation, and before this evaluation, before all 3 evaluations, they were given different post-editing guidelines or different task guidelines in order for them to know which were the requirements of the task and what they had to do. After this, in the post-editing evaluation, I said before that there were 2 different texts. On the first side, this was divided because in case evaluator 1 did the text 1 with engine 1 and engine 2, after evaluating the text with engine 1, the text 1 with engine 1, they would know the terminology and the proposals for engine 2. This way, we change and we put text 1 with engine 1 for evaluator 1 and text 2 with engine 2 for evaluator 2. In changing it for evaluator 2, we did this different thing, and then we put text 1 and engine 2 and text 2 and engine 1. This way, every evaluator did 2 different texts with 2 different engines. This was later mixed, and we obtained the results that I'm presenting right now. First of all, in MT ranking, on the first chart, we can see the percentage of times an engine has received ranking 1 evaluation, so the best evaluation, which was the MT engine that offered the best quality raw proposal, and Softcatalà translator wins. It's in the first place with a 40.6% against Google Translate that is in second place with a 39.7%. It's not a big difference, but if we move to the second chart, we can see the ranking distribution per engine in percentage. Softcatalà translator gets 62.27% times ranked as the best MT engine, whilst Google Translate moves it's in the second place with only 58%. Here the difference increases, and if we inspect the results more thoughtfully, from all the 11 evaluators, 10 said in this evaluation that Softcatalà translator was the MT engine who proposed the best MT proposals, while the last person, that 11th evaluator that didn't say that, said that there was a draw between Google Translate and Softcatalà translator. Then in terms of fluency and adequacy, we can see that in fluency, Softcatalà translator is on the first place too, and Google Translate in the second place. There's a difference from 65% to 61%, while Apertium, that it's a rule-based machine translation system, it lags really behind with these fluent and some incomprehensible evaluations. That means that it's way behind than Softcatalà translator and Google Translate. In terms of adequacy, we can see that Softcatalà Translator is also in the first place, but increases its difference in regarding Google Translate, and it moved from 60.5% to 48.5%. From this chart, we can see and we can state that neural machine translation offers a better fluency rather than rule-based machine translation, as well as adequacy. And while both first systems, Softcatalà Translate and Google Translate, offer good fluency, in terms of adequacy, Softcatalà Translator has a bigger difference rather than Google Translate. Regarding the third evaluation, in posterity and productivity, in this first group of study among Softcatalà and Google, we can see that the posterity time in seconds of 100 segments or 200 segments, 100 segments each text, 200 segments in total, it's 3,909.07 seconds, while Google Translate is 4,131.64 seconds. That's 222.56 seconds of difference, and that means that we get a 5.69% percentage productivity increase using Softcatalà Translator rather than Google Translate. So we would translate faster and more words with Softcatalà Translator than with Google Translate. We can also see that in edit distance, that means that if the number is closer to 0, we have to do less amendment rather than with Google Translate. And this data, edit distance, the data with asterisks are statistically significant. So that means that edit distance is statistically significant in this study, but not posterity time. We would need to increase the segments evaluated or even increase the number of posteritors. I then did a more precise evaluation among different sentence length, and Softcatalà Translator wins in posterity time against Google in short and medium sentences, but loses in long sentences from 16 or more than 16 words. Regarding the second group of study.
Sorry for interrupting you. 5 more minutes. Thank you.
Okay. Regarding this second group. Regarding this second group of study among Softcatalà and Apertium, Softcatalà Translator, as we saw also in previous charts, it's way before Apertium, and there are a difference in posterity time, a median difference of 1,883.89 seconds of difference, that is 101.31% productivity increase. This was really useful for Softcatalà, as they are normally localizing software with these machine translation systems, and they wanted also to know which would they use or which is more useful for them. And finally, I'm going to present, or I'm going to conclude after seeing all this, which is the impact and effects this machine translation for low resource languages has. First of all is normalization. As I said, in the closest situation where two languages cohabit in a same area, normally there's one language A stronger and one language B that is weaker. In this case, Catalan is weaker, and this having machine translation in these cases would help Catalan to gain presence on the internet or even on society, to talk to administration, etc. So smaller groups of the society can talk and can communicate and can normalize their language with the society, politics, and even with administration. Then it also helps to language diversity, because we avoid language shift to predominant languages. That's related with the previous, and then it fosters language literacy. Small groups of people know, for example, Catalan in the Valencian country or less than Spanish, and that's increasing right now thanks to machine translation systems or even a normalization that is taking place. We can also gain data privacy and respect it. That's also really important, and it's one of the most important and research things right now, because confidential information is preserved, and we can use this both for our personal information or even for clients' information in case we are professional translators. And at the end, this will also help in crisis scenarios, for example, in multilingual communication to reach everyone, in natural disasters, or even in current COVID pandemic, where probably safety measures are not available in Catalan, but they are in Spanish, and it may not reach some people. And this is everything. Thank you for your attention. And if you have any questions,